Hello and welcome, dear viewers, to the very informative topic on dissolution conditions. And in this present video, the sink and non-sink conditions will be studied in detail. And in this video, you will get the complete understanding about the sink conditions. What are sink conditions? Why these are required? How to achieve the sink conditions? And what if the sink condition is not achieved or is not practical to achieve the sink condition? What are the justifications required to prove the dissolution testing under non-sink conditions? So, sink condition is a topic of great interest for the interviewers, as dissolution testing is the performance testing for solid oral formulations and also for the liquid oral formulations. So let's start with the video. See, before understanding the sink condition, a simple experiment you might have performed at home. So if you take a glass of water and you keep on adding sugar into that water and stir it, so initially the sugar will dissolve very rapidly, and if you keep on adding the sugar into the water, it will take more time to dissolve, and after some time it will start collecting at the bottom and it will not dissolve. So that means the capacity of the solvent to dissolve the sugar is over, that is solvent capacity or solvency, you can say that. And now the sugar will start to get collected at bottom, and that is the saturation level. At that time you can say that the solvent is saturated and now it cannot take up the another quantity of sugar. So that is saturation. And the quantity soluble into the water at saturation, it is called as the maximum solubility of the material, or in this example it is sugar. Now we will see what is sink condition. See, sink condition means the volume of dissolution medium that is at least 3 to 10 times the saturation volume. If the saturation volume is 100 ml, then you can say that at least 3 times, means 300 ml to 1 liter will be the sink condition, will give you the sink condition. In other words, the volume of the media being at least 3 times of that required to form a saturated solution of the drug substance. If sink condition is maintained, at that time the amount of the drug already dissolved in the media does not affect the dissolution rate as the run progresses. That means the medium of the dissolution should be such that it is 3 times the volume that is required to form a saturated solution. If 100 ml is the saturation volume, then dissolution medium will be at least 3 times to 10 times to the 100 ml saturation volume. Now, what is a non-sink condition in the dissolution test? If the volume of the dissolution medium does not dissolve the 3 times of the drug dose or amount of the drug, then it is said that the condition is non-sink or sink condition is not achieved. And how this non-sink condition is derived? It is derived from the solubility in mg per ml of the media. In the last slide we have mentioned that the volume is 3 times to that of the saturation volume, and now here we are saying that the volume of dissolution medium does not dissolve the 3 times of the drug dose. So these are the same terminologies. If the dose of the drug is 500 ml then the medium should be able to dissolve at least 1500 mg, or media volume should be such that it is 3 times to that of the saturation volume for 500 mg dose. So it is the same thing. Then how sink conditions and non-sink conditions are determined? So mainly sink conditions are determined based on the solubility, that is called as equilibrium solubility, and the saturation solubility. Based on the solubility of the drug in the dissolution medium, this condition of sink condition or non-sink condition is determined. Saturation solubility or equilibrium solubility studies are required to be performed on the drug substance, and based on the mg per ml solubility and the saturation point of the drug, we can derive the sink and non-sink conditions. We must know the saturation point of the drug for the formulation to understand the sink condition. Here I have taken an example of drug. The drug solubility in the dissolution medium is 1.3 mg per ml, and the dose of drug per unit, that means you can consider the tablet or capsule, it is 250 mg. Now based on this solubility mg per ml, volume of media required to dissolve or to form a saturated solution is 250 divided by 1.3, it is 192.3 ml. So this is the media volume that is required to dissolve 250 mg of the dose, and 250 mg dissolves in 192.3 ml. That's why it is the 1x of the volume, that is saturation volume. Now if you want to calculate how much is required for the sink condition, then you simply multiply the saturation volume by 3. You will get the sink volume in which the volume in which the sink conditions will be achieved. And now if the media volume is above this is used, then it can be said that the sink condition is achieved. Another example is sink condition. V by V sat, it should be equal to or greater than 3, where V is the volume of dissolution medium in one vessel and V sat is the volume required to form a saturated solution of the drug. Suppose volume of dissolution medium is 500 ml and volume of saturation solubility is 100 ml. That means 500 divided by 100 will give you 5, and that's why if it is more than 3, that is it is 5, so sink condition is achieved. Now how the sink conditions are taken as at least 3 times. Somewhere it is also written that it is 5 to 10 times or minimum 3 times. So how it came into the picture that 3 times volume is required. Now you consider the Noyes-Whitney equation that is given for the dissolution rate of a solid into the solvent, and it is given as R is equal to K2 into ds by Vh in bracket Cs minus Ct, where the R is dissolution rate, here is the dissolution rate or rate of dissolution, and it is dependent on the intrinsic dissolution rate, then the diffusion coefficient, the surface area, volume, and the thickness of the stagnant layer. And now here in this it is given as Cs minus Ct. So this is very much important here. This Cs is saturation constant of API and Ct is API concentration at time t. So saturation constant of API means you can consider it as a saturation point for the solubility, and Ct is the API concentration at time t. Now based on that equation we can consider whether the sink conditions are related to the in vivo and in vitro, that is in vivo means in the GIT and in vitro means the dissolution vessel. So many of the people understand that if the dissolution media is replenished or replaced with the fresh media, that means the sink condition are achieved. It is not exactly the same. The sink condition is somewhat different from that replenished media. So we will consider the in vitro and in vivo sink conditions. We have understood the Noise-Whitney equation, and from that we considered the saturation constant of API and the API concentration at time t, that is CS and the CT. So now that we have to relate here with the in vivo and in vitro sink conditions. So if you consider the sink condition in vivo in the GIT, and if you consider dosage form as tablet formulation, the tablet is taken by oral route, then the tablet will disintegrate, the drug release will happen, and in vivo dissolution will be followed by absorption. So the GI fluids not get saturated as the dissolution and absorption go on continuously. So in vivo the sink is maintained. CH is the saturation or constant of the API. CT is the API concentration at time t, and in vivo CS will not be equal to CT, and it is not possible that CS will become equal to CT. That's why the sink condition is maintained in vivo. Now if you consider the in vitro sink condition, that is in the dissolution vessel, so tablet disintegration will be there, drug release will be there, and the dissolution media is same and it remains into the same vessel. So there is no absorption or there is no take away of the API concentration from the dissolution media. So the volume of the dissolution medium is same and it may get saturated. That means here in vitro the CS may come to CT. Further dissolution may stop because of the non-sink condition. To have a robust dissolution method and to detect the formulation differences, the sink condition is required. Otherwise, dissolution stops due to the saturation of the media. Once the media is saturated, then the media will not take the further amount of the API for solubilization, and that's why the dissolution will stop. As per the equation, the dissolution rate R is proportional to the CS minus CT, and at the start of the dissolution, consider the CS as 3 and CT is 0. That means your API is not going into the solution at time 0. And if the saturation is 3, as the dissolution goes on, CT increases. That means the drug will go into the solution. Consider the CS is equal to C and CT is 1. Then the CT will go on increasing and CT will go to 2 and it may go to 3. When the CS and CT is equal to each other, then the dissolution stops. That's why if CT is equal to 2, at this time the dissolution may get slowed as the CT is increasing, and if it becomes 3, then the dissolution will stop. This condition is not required. Also, along with the API, the other materials are there which dissolves into the media. Also, the soluble materials take the solvent capacity, and these materials will also have impact on the solubility of the API. Thus, to avoid the problem, saturation, the 3 times media is required. So this is the simple understanding about the saturation point and the drug concentration into the media at time t. That's why to avoid the saturation of the media, generally the volume of 3 times to the saturation volume is taken for the dissolution testing. Now why sink is required? This is to avoid the robustness issues in your dissolution method, that is day to day variation, variation due to small changes into the volume. Then the dissolution method may not give true discrimination, or the dissolution method will not have that much discrimination power if the sink condition are not meeting. To ensure the rapid and complete release of the API, that means to achieve the extent of the dissolution, the sink conditions are required. If media approaches the point of saturation, then the dissolution rate cannot be consistently measured. Also, to avoid the stop in dissolution rate or stop in the dissolution due to saturation of the media. To, to make the dissolution test as a test to reflect the formulation performance and to detect the changes in the formulation. That means simply the dissolution method should be robust, consistent, and it should have a discriminatory power so that the good batches and bad batches, by equivalent and by inequivalent batches can be checked and reflected from the dissolution results. Then also sink condition are required to make the dissolution test as a test for in vivo prediction, that is IVIVC. So here I have taken a example, dissolution in different pH medias. Consider the drug have a different solubility profile in the different medias. The media is taken as pH 1.2, 4.5, 6.8 and water. So here in the pH 6.8, the solubility is more compared to the other medias, and at 60 minutes the extent is available, that is dissolution is more than 80%. That's why this 6.8 pH can be selected. Here if you see, the complete release is not achieved in other medias than the pH 6.8 media, and in pH 6.8 there is a gradual increase in the dissolution. Saturation is not achieved. Here because of the solubility problem, the saturation is there, that's why the dissolution is not progressing. So in this case, based on the solubility, the dissolution media of pH 6.8 can be selected, and this media will give a sink condition. The second example is the API or formulation with the less solubility in water, and the solubility get increased with different concentration of SLS. So water is used as a media, and water with different concentration of SLS is taken. Here you can see the water with 0.2% SLS is giving a good solubility and sink condition, but after increasing the SLS percentage from 0.2 to 0.5, still there is not much increase in the dissolution. So you can consider that water with 0.2% SLS is sufficient for getting the sink, and here surfactant is used to have the sink condition. Now why the sink condition is required, you can check from this simple graph. If you take a non-sink condition or the media with not meeting the sink condition, here saturation is there for the media, that's why the dissolution is stopped after some time. But if you take the sink condition, here the dissolution is increasing and it is the complete dissolution. So to avoid the saturation of the media due to non-sink conditions, you can take the other medias which are meeting the sink conditions. Now what are the over sink conditions? If the media volume is too much higher than the sink condition requirement, then it may lead to the under-discriminatory dissolution testing. If you can perform the dissolution in 500 ml of the media and still you are taking around 1000 ml, then you can say that this is the over-sink condition. Then the over-sink condition may lead to less in vivo prediction and less chance of detection of formulation differences. You can also say this condition as a under discriminatory condition. For highly soluble APIs like BCS class 1 and 3, though these APIs are highly soluble and very less media can be required, but still the dissolution volumes of 500 ml can be taken and the standard dissolution conditions can be done for dissolution testing. Now, what are the factors affecting sink conditions? So, mainly the media specific solubility. Media specific solubility may have impact of pH, impact of ionic strength, impact of presence of or absence of the surfactants, then precipitation of the drug in the medias, temperature, dissolution apparatus and agitation. See, if you have the volume greater than the saturation volume and still it is not a guarantee that you will get a complete drug release, because only the sink condition cannot guarantee the complete release, because it have a effect of dissolution apparatus and the agitation. Agitation means the RPM of the paddle apparatus or basket apparatus, or dips per minute for the USP3 apparatus, or flow rate for the USP4 apparatus. Now, excipients and the formulation design also have a great impact on the sink conditions. Sampling volume in the dissolution testing is an important parameter which affect the sink condition, because it replaces the media with the fresh media. Now, how to achieve the sink conditions? If you have a drug which is not giving the sink condition in the generalized media of 500 ml, 900 ml or 1000 ml, then we have to check the media in which the drug substance is having higher solubility and whether that media can give you the sink condition or not. So by media selection, check the effect of pH, buffer, ionic strength. Then by increasing the dissolution volume, also the media hydrodynamics, apparatus and agitation affects the dissolution and play a great role in the dissolution testing. If you have a highly soluble drug substance and you have taken a 500 ml of media, but the RPM of the paddle apparatus is around 25 RPM, then you may not get the complete release because of the less hydrodynamics. Then we can use the surfactants so to increase the solubility, and that's why we can get the sink condition. Then we can use the solvents or we can use the hydroalcoholic media to have a sink condition, but it is not recommended and it is very difficult to justify, because in vivo there is no hydroalcoholic media and generally the buffers, aqueous buffers are used which are in the physiological pH range. We can use the USP3 apparatus or 4 apparatus, as these two apparatus have a more dissolution media volume. We can increase the media volume and we can also change the USP3 apparatus, or we can also use the USP3 apparatus and 4 apparatus. Then we can change the media volume, pH, composition during the dissolution run. That is sequential change in the media. Once the media gets saturated, then you can change the media or you can change the composition or pH of the media, and like this you can achieve the sink conditions. The sink condition alone does not give the assurance of avoiding the saturation or slow down of the dissolution or stop of the dissolution rate. Why? Because other conditions which impact the sink condition are media hydrodynamics, apparatus and agitation, of the apparatus. See, till now we have discussed that the sync conditions are required. But if by any means you are not able to get the sync conditions, then can you perform the dissolution or can you develop a product? So yes, without sync condition also the product can be developed and it can be filed to the regulatory authorities. As the sync conditions are achieved when there is a media volume which is more than the 3 times to the volume of saturation volume, or if the media volume is able to dissolve the 3 times of the dose, then it is called as sync condition. But if you select a media or if you study the media and you come to the conclusion that the media can only dissolve 1.5 times of the dose, so that time the sync is not maintained or sync is not achieved as per the definition. But the media is able to dissolve around 2 times or 1.5 times or 2.5 times or less than the 3 times of the dose. Still you can perform the dissolution testing. See, sync conditions are not mandatory. These are desirable to have, and a dissolution testing can be performed in the volume below the 3 times to that of the volume required to form the saturated solution. Sometimes it is not possible to have the sync conditions for those APIs for which the dose is higher and the solubility is very low. Now see when and how the non-sync conditions can be taken into consideration. So non-sync conditions refer to the situations where the concentration of the drug substance in the dissolution medium is not significantly lower than its solubility. That means your media is able to dissolve the dose 1.5 times, or you are taking the volume which is able to dissolve at least 1.5 times of the saturation volume, or if not at all possible it should be able to dissolve 1 time of the dose, that is volume is equal to 1 time to the saturation volume. That means the media volume and the saturation volume is same. Now if you go above this, then you will get more volume or you can dissolve more amount of the drug substance from 1 to 1.5, then 2 and 3. If you go beyond 3, then you can achieve the sync condition. But if it is not practical to have the volume more than 3 times, then 2 times, 1.5 times or 1 time also can suffice the requirement. The examples are low soluble drugs like BCS class 2 and 4. For some of the drugs, achieving sync condition is not possible by any means. You may use the surfactant or agitation or the ionic strength of the media or whatever, but still if you are not able to get the sync condition, then non-sync condition can also help for understanding the formulation differences and prediction of in vivo conditions. Then some of the formulations are administered as multi-unit at a time, so testing the single unit in the dissolution may not give the true picture. And based on these characteristics of the formulation and the API, the applicant can justify the use of non-sync condition for the dissolution testing. As for some of the low soluble drugs, it is not possible to have the sync condition. Then for some of the extended release formulations and the solubility enhanced formulations, the sync conditions are very difficult to achieve. And sometimes the non-sync conditions can give a good understanding about the formulation performance. See, in the extended release, modified release, controlled release, prolonged release and other formulations in which the dose is higher than the higher formulations, for those formulations it is very difficult to have the sync condition. This formulation release the drug for a longer time, and that's why may lead to the drug released above the solubility limit of the media. The recrystallization and precipitation behavior of the formulation with solid amorphous technology, that is solid dispersion technology, nano suspension technology, or in the solubility enhanced formulations, these formulations can be tested into the non-sink conditions, and these non-sink conditions will be more predictive for in vivo performance of the formulation for these type of formulations. The functionality of the excipient can also be tested in non-sink conditions. If you are making a solid amorphous dispersion and you want to check the functionality of the polymer to have impact on the solubility, then non-sink condition can give more information about the excipient performance. Then whenever we are using non-sink condition, then what type of justification is required? So the justification should give the details about the API solubility study and the data. Then whatever the efforts taken by the applicant or approaches for the studies to achieve the sink conditions, these are to be given. Formulation design and excipient used should be enlisted, and the justification is required to be given. Then the applicant has to prove the discrimination power of the dissolution method. The biorelevancy and the IVIVC and the robustness of the method should be given and justified. Then data to support that the non-sink conditions does not lead to a method which is not discriminatory. That means the applicant should justify to the authority that though the dissolution medium or dissolution conditions are not meeting the sink condition, but still the non-sink conditions are not leading to a method which is not discriminatory. That means in the other words, the non-sink conditions are there, but still the dissolution method selected for routine testing of the formulation is a discriminatory method, and it can detect the good and bad batches. So this is how the sink conditions are required, then how these are determined, and when there is a problem of getting the sink conditions, then how non-sink conditions can be used and what are the justifications are required. See, whenever we are working in the professional field, we should have the complete understanding about the topic. These dissolution topics are very much important, and these are the topic of great interest into the interviews, and you don't know when and where which interviewer may ask you about the questions on dissolution, and you will or you will not answer to those questions. So complete understanding is very much required. Whenever we are going for the interview, we study the literature, but understanding the things in 1 day or 2 day or in a week will not give you the complete understanding. So learning is a continuous process, and the professional people should learn on a continuous basis, because we don't know whenever the interviewer will ask the question and whether we will be able to answer. Sometimes the interviewer asks only 2-3 questions on the topic, and from that answers they get the prediction that the candidate is okay for the job or not. So I hope this video might have given a good understanding about the sink and non-sink condition. If you have any of doubt, you can provide the question into the comment, and I will be happy to answer the questions. Please do like, share and subscribe to this Pharma Learning in Depth channel. Thanks for watching.